Okay, so section 8.4 in the textbook has to do with Hund rule, which has to do with doing orbital diagrams. Again, orbital diagrams just show the electron configuration with the electrons at each cell. Hund's rule says that the lowest arrangement of electrons subshell is obtained. So basically, I want to fill up in one direction prior to starting to pair my electrons. So this one is wrong because I put in this electron here prior to having filled up this orbital over here. So it says write the orbital diagram for the ground state of samarium, Sm, and it gives me the electron configuration is Xe, so that's the noble gas, 6s2, 4f6. Okay. So when I'm doing the orbital diagrams, I still have to write down the Xe. Okay. S has how many orbitals? 1. So I draw 1 dash and put the 6s underneath it. F orbitals, there are 7 of them. So 1, 2, 3, 4, 5, 6, 7. Alright, so I have 2 electrons in the S. Oops, I need to label this as being 4F. Okay. And so I have to fill up the S first, and since S only has one, I have to put, or only has one orbital, I put both electrons in there. Now to do the F, I go up 1, 2, 3, 4, 4, 5, 6. And so that is the orbital diagram for the ground state of samarium. Also, we can predict, using orbital diagrams, the magnetic properties of atoms. So there's an attraction or repulsion based on the electron configuration. A paramagnetic substance is something that's attracted to the magnetic field, and that's any atom that has unpaired electrons. A diamagnetic substance is repelled by a magnetic field, and that only occurs when I have paired electrons. So this video, in which the address is down here at the bottom, shows the magnetic properties of water. So this is a glass rod that they've rubbed wool on to make it magnetized, and you see that whenever you bring the glass rod close to a small stream of water, it actually diverts the water towards the magnet, which will make it paramagnetic. And so just to show that it can happen on either side, they're putting it on both sides there. The closer it is, the more diversion you have. The further away, the less diversion. Okay, it has to be magnetic. That steel ball is not magnetic, so you see no dB. Oh, you do see some. It's a much weaker magnet. I'm sorry. If you look at the very bottom of the screen down here, you can actually see it moving a little bit. But it's a much weaker magnet. Okay. So, the next question wants the orbital diagram for the ground state of zinc, and is it diamagnetic or paramagnetic? Okay, zinc is, zinc is right here on the periodic table. Okay, so using the noble gas configuration, it does not specify, so I'll actually do it both ways. Okay, you can do the electron configuration first, but I'm asking for orbital diagrams. So if you do the electron configuration, you also have to do the orbital diagram, or you should be able to just do it the other way. So I'm going to use the periodic table. I'm going to do the long form first. Okay, so I have 1 dash, which is 1s, and it has 2 electrons in it. 1 dash, that's 2s, and has 2 dashes. Then I have 2p, p has 3 dashes. And 1, 2, 3, 4, 5, 6. So kind of keep track of where I am. This was my 1s. This was my 2s. This is my 2p. So down here, this is 3s. So I have 3s. Then I do 3p. I'm going all the way through it. So 1, 2, 3 is 3p. So 1, 2, 3, 4, 5, 6. I do the 4s. Has 2, 1, 2. And I count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, so this is 3D because remember for the D's it becomes the row number minus 1. So, and D has 5. So 1, 2, 3, 4, 5. And I'm going over 10. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And this is 3D. So that's using the long version. Okay. To do the short version, erase this down here. Okay. To do the short version, I'm going to start with argon. I'll circle it. Okay. So argon is my noble gas before zinc. And then this is on the 4th row. So I have my 4s, and it coming through there has 2 electrons. I've already counted over, so 1, 2, 3, 4, 5. This is my 3D, so I do 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So this is the, let's see if I can change the color here. To purple. This is using the noble gas configuration. And this is the long form. Okay. All right, and then it also asks for if this was paramagnetic or diamagnetic. Okay. If I look at this, all my electrons are paired. I really only have to look at the last orbital. Okay. Here. All right. And all my electrons are paired, and so that becomes the diamagnetic. Okay. And that is the end of that presentation.